I want to talk briefly about how to hold threaded items in a lathe. Now, when I first got started, the first project I wanted to do involved machining on threaded rod or bolts just like this. And the problem is that the chuck here can damage the threads. Another problem is, depending on the quality of the material you're starting with, it may not be concentric. For my project, I was interested in machining off the head of the bolt to end up with something like this, which means I had to hold the threaded end in the chuck. Now, while researching methods of chucking up threaded items, I found people who were interested in machining the other end of bolts, and they would simply chuck the hex head of the bolt in the 3-jaw chuck, which fits very nicely. The problem that I found with this is that the head of the bolts are typically not concentric. You can see pretty clearly here that there's a lot less material on this side than there is on this side. There are many ways to hold work pieces for machining, and this is a grade 5 bolt. The first time around I actually just chucked it in there and everything went pretty smoothly. I was able to turn down the head of the bolt, nothing moved, and it worked out all right. I didn't feel very good about the interface here, but it worked. Now this threaded rod is another story. This is not hardened, it's very soft. You can see there's a ding in the threads right there already. My first time around, what I did is I actually just wrapped a piece of aluminum around the threads, like that, and I used that as a cushion between the jaws and the threads. This actually worked okay. You can see this aluminum did take a beating inside and out pretty quickly. You know, this is just a small scrap, so it's easy to replace, but I wasn't totally satisfied with this. I did need to rearrange the part a few times, and I found that this wasn't providing very good repeatability, and I just still wasn't quite happy with it. After seeking some advice, I got some good suggestions, such as making a split bushing, where you would basically take a piece of pipe. It can be soft or hard. It's the right diameter to be a close fit to your material, which this is not, but you could simply slit it in 1 or 2 places and use that around your threaded material. Same concept as this. Or a split nut setup, where you could actually do the same by cutting a nut in 1 or 2 places, and the threads of the nut should thread well into the grooves to begin with, and then the clamping pressure should help hold it even better. This idea I liked. It was getting me to where I wanted to be, but I still wasn't happy with the idea of 3 jaws of the chuck compressing an item that can only be compressed in 1 or 2 places where the slits are, but it was a move in the right direction. It was the split nut idea that got me thinking about collets. Collets are basically devices with a specific size bore made for holding tools or work. This is a 7/8 collet and a 7/8 bolt. It's a pretty tight fit. And then when this taper is engaged, it causes these fingers to squeeze closed and create a nice tight fit. Now, what I like about this R8 collet is that it's got 3 fingers and my chuck has 3 jaws. What I didn't like about the collets is the fact that we're still dependent on the concentricity of the outer part of the threads here, which may or may not be accurate. Following up on the concept of the R8 collet with its 3 fingers brought me here. This is a homemade collet. It's threaded to match that, and it's got the 3 fingers so that when the threads are engaged, and it's actually threaded so that it's a pretty tight tolerance. You can see that spins freely, but the moment I squeeze it, it's very tight and hard to turn. And that's just with my hand squeezing it. So once the chuck is squeezing against it, like that, it's not going anywhere. So that's what I came up with, and I found that it works very well. It's still not perfect, but we have a nice thread inside that has a very tight tolerance to these threads, and our jaws are clamping concentrically in 3 directions against it. This is made out of aluminum, which can conform a little bit to this. In fact, do you remember this piece of copper pipe that I showed you earlier? In fact, what I did is I melted down some scrap aluminum and I cast it into a piece of this, which came out looking something like this. I was able to machine that down, and I drilled the proper size hole, and then I used a boring bar with a single point to cut the threads on the inside until I got a nice tight fit. Next, I put it in the mill and I milled these slots out. How could this be improved further? I've been thinking about that, and probably by eliminating the chuck altogether. Most spindles have a taper inside of them, which can accept a collet, or you can put a collet chuck on there. For example, here's an ER40 collet, and you could custom make a collet and thread the inside just like the aluminum one that I made, and have that go straight into the spindle or into a collet chuck, and that would eliminate the run out that you have from your 3-jaw chuck. So that's what I learned about holding threaded items in the lathe. You know, this is simple but functional if you're just doing a quick job. If you're going to be doing production work, then you might want to do something a little more intricate, and I'm happy with this. It works well for me. And for milling, we can use the same concept by taking a 3-jaw chuck with a nice flat backside that will sit true on the table of our mill, clamp that down, and then simply clamp the same collet into the chuck. As I venture into the hobby of machining, I find it very enjoyable to solve problems like this. Finding ways to simply hold a material can be time-consuming, but very satisfying in the end. So best wishes to you, and be safe.